Good evening, everyone. This is our presentation for MEC 523 Arduino project. Our project title is Arduino Based Greenhouse, and our group is group number 4. This is our team members, which is Muhammad Faris Farhan bin Aslan, Muhammad Najib bin Ahmad Hamdan, Muhammad Afiq bin Aslan, and lastly, me, Melvin Anilajim.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najib, and I will give a short brief about our Arduino project. So for these past few weeks, we are working on this Arduino project to build an Arduino-based greenhouse. So the reason behind this idea is because we are trying to keep up with the current issues regarding climate change, which continues to impact the global weather pattern, which is eventually affecting the traditional farming system. So, how does the greenhouse overcome this problem? In general way, we can say that it can control the environmental factors of the plant by using Arduino technology, which is known for its friendly programming environment and powerful hardware capabilities. The project makes it easier to create smart greenhouse that capable of precise environmental control, data collecting, and automation, from optimizing temperature and humidity levels to automating irrigation system. This initiative is intended to transform how we approach sustainable agriculture.
Good evening. So we have discussed four problems that we need to solve during the development of this project. So the first one is that traditional greenhouse gardening has a tough time keeping plants happy under the perfect conditions. This results in crops not reaching their full potential and a waste of precious resources such as fertilizers, plants, and space. And the next one is the variation in temperature, humidity, and light intensity occur due to manual monitoring and control. This will result in a inconsistent plant growth and increase in resources consumption. And then the next one is that the lack of real-time data monitoring and automated control system will hinders the ability to make informed decisions promptly. In this case, we'll be talking about uh, when the owner of the plants are being too busy with his job, making that making that he or her will not be able to spend or committed his time to his or her plants. And the next one is, and the last one is that gardeners struggle to achieve precise control over environmental parameters like temperature, humidity, soil moisture, and light levels. So throughout in the development of this project, we'll be making all of these parameters to be controlled automatically. That's all from me. I will pass the floor to Muhammad Najib on his objective discussion.
There are three main objectives of our Arduino project. The first one is to enhance the efficiency, sustainability, and productivity. So, how can we relate this? The precision of environmental control. It can control of environmental factors such as temperature, humidity, and light to create optimal condition for the plant growth. So the next one is to develop a cost-effective solution due to its accessibility to a broad array of farmers, promoting the adoption of advanced technology. The last one is to offer scalable and adaptable solution. The design of the system can be customizable, depend on the user preference to suit the agriculture needs.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Farhan bin Azlan, and today I will present the methodology part. In methodology, we use several components such as Arduino Uno, which is used as a microcontroller for this project, and breadboard, which is the construction base for circuit. Next, we have used soil hygrometer, which measures the dryness or moistness of the soil using the concept of resistance and conductivity. Then DHT sensor measures the temperature and humidity of the surrounding air. Next, photoresistor measures the brightness around the surrounding environment. Other than that, we also use ultrasonic sensor, which measures the distance between the component and the obstacle in front of it using sonar. Next, the LCD display or light crystal display. This display allows any numbers or words to be displayed on the component. Other than that, the water pump, which allows the pumping of water into the plant. We also use relay as a way to control the component that requires more power than what the microcontroller could supply. Relay is used in this project as a switch. Then resistor, which is 10 kilo ohms. It is used to reduce current flow. Other than that, we have used LED light. When turned on, the component will shine a light. Next, piezo buzzer. This component makes noise. Finally, the wire. This allows us to connect components into a complete circuit. Given here is the cost for Arduino Uno, wires and breadboard. Next, the cost for soil hygrometer, DHT sensor and photoresistor. Other than that, the cost for ultrasonic sensor, LCD display and water pump. Moreover, the cost for relay, resistor and LED light. Finally, the cost for piezo buzzer. And the cost of all of these components added up together, it counts for the total price of 96 ringgit and 92 cents. This is the circuit diagram. As you can see in the diagram, all of the components that we have used for this project have been laid out as a way for you to replicate it if you feel like it. Also included are several more additional explanations, such as the LCD display to the right, which allows you to understand which pin goes to which pin. For this next section, we will talk about the coding of our project. In this first page, we can clearly see the first lines of our code. For this section, specifically, is the declaration and initialization for our project. Next is the void setup section. This is where the section where the code will run only once and then it will no longer run again. It is not a loop. This is our setup for our coding. The next section is void loop. This is all of the codings we have, where the code will go through every single line and after that it will loop again from the top. For this specific section, this is the code for soil moisture ultrasonic sensor. This next section is for the piezo and the light sensor coding. At the top from 71 to 76 is still the code for ultrasonic sensor. Next section, which is this section, is a section for DHT sensor. As you can clearly see, this is all of the code required to run a DHT sensor component. Finally, this is the section for display, where the LCD display will display all of these variables that ever changes thanks to the DHT sensor.
So let's move on to result of our project. This project used 4 sensors and all 4 sensors work as programmed. First sensor is soil hydrometer. The water pump turns on when the sensor detects dry soil. Second sensor is DHT sensor. The temperature reading detected by the sensor is displayed on the LCD display. Third sensor is photoresistor. The LED turns on when the sensor detects darkness. And lastly, ultrasonic sensor. The alarm beeping when the sensor detects something close to the greenhouse. Following are the demonstration of our product. Okay, for discussion, Arduino-based greenhouse allows for real-time monitoring and control of environmental factors such as temperature, humidity, and soil moisture. By collecting data and making automated adjustments, the system can optimize resource utilization, ensuring that water, energy, and other inputs are used efficiently. This is not only contributes to cost savings, but also promotes sustainable and eco-friendly practices in agriculture.
So we have went through all the details about this project, including demonstration. So what we can conclude from this project is that the Smart Arduino Greenhouse Garden System aims to address problems with conventional greenhouse farming by providing gardeners with exact control of essential environmental components. By optimizing crop yields, improving plant health, complying with eco-friendly standards, and also to contribute to a more resilient and sustainable agricultural system. If it is developed in a big application, the system has the potential to have a significant impact on the agriculture. So imagine how people apply Internet of Things or IoT in their farming. Imagine how big it will be and how big it will impact the society in terms of sustainability, job qualification, and many more. So that's all from us. Thank you.